In this episode, we're going to look at Mixed Mode Clock Manager Primitive, or MMCM, one of FPGA's many powerful capabilities. A mixed mode clock manager is similar to a phase-locked loop, or PLL, in that both of them can be used to generate multiple clocks with arbitrary defined phase and frequency relationships to a given input clock. But a mixed-mode clock manager has a couple other advanced features, such as fine dynamic phase shift and modulated spread spectrum control of generated output clocks. We're going to demonstrate an example design utilizing MMCM running on the PINC Z1 board. In this example design, the FPGA would take in a 125 MHz clock input and use a MMCM to generate 4 output clocks at 10 MHz, 20 MHz, 30 MHz, and 40 MHz. For those of you that don't have access to a handy oscilloscope to probe and validate the clock outputs, the example design also includes a trick to use the 4 onboard LEDs to help with this validation. The 10 MHz clock output is probed and captured. Notice that each LED has its own timer with a varying rollover count that tracks the individual clock speed to guarantee the same absolute 1 second of time. This means that if one or more clocks do not have the correct frequency, this would mess up the interpretation of 1 second, and the LEDs synchronized by those incorrect clock speeds would blink erratically instead of in unison with the rest.